Here we have an RC circuit. The capacitor is initially uncharged, and we close the switch at time t equals 0. We want to know when the potential drops across the resistor and the capacitor are equal to each other. So let's think about what happens initially when we close the circuit. So as soon as we close the circuit, the capacitor begins to charge. And a charging capacitor, the charge on a charging capacitor follows this equation. So at t equals 0, e to the 0 is 1. So this is 0, so the total charge is 0, just as they told us. So that's good. What is Q max? So Q max is the value of the charge on the capacitor when there's no more current flowing through the circuit. So when there's no more current flowing through the circuit, the drop across the resistor is 0, so the capacitor is fully charged to the voltage of the battery. So that means that Q max has to equal the voltage of the battery times C, because V equals Q over C. So that's where this came from. So that means that our equation for the charge on the capacitor is actually EC times this exponential part. Okay, so now we know by the loop rule that the sum of the voltages around the circuit, or around any loop, has to be 0. So if we start here, we first go over the battery. So that's just the voltage of the battery. Then we're going to go across the resistor, so that's minus IR. And then across the capacitor, so that's minus Q over C equals 0. Now, if the voltage drop across the resistor is equal to the voltage drop over the capacitor, then they each must have to equal 1/2 times E in order for this to be true. So that means that Q over C has to be 1/2 E. So let me just write that down. 1/2 E equals Q over C. And Q is a function of time, so if I plug this in here, the C's will cancel, so I'll just get the voltage times 1 minus e to the minus t over RC. And these e's will cancel, and I can move the 1 over here, so I'll have minus 1/2 equals minus e to the minus t over RC. Take the log of both sides. And if I solve for t, so I plug in my values for the resistor and the capacitor, I get that t is 0.208 milliseconds.